Hi everyone, today we're going to be discussing the properties of real numbers. At the end of these notes, you're going to be able to say this learning target, which is I can identify the properties of real numbers. The reason why we need to understand these 16 properties is because they will help us be able to simplify numerical and algebraic expressions, and they're also going to make solving equations a little bit easier for you. Okay, again, since there are 16 properties, I want you to hang tight and enjoy this ride. There is a lot of text. You're going to be taking notes, so throughout this video, I encourage you to take breaks, but it is important for you as an algebra student to take all of these notes because all of this information is important. Some of these properties you may be familiar with from previous math classes. Others are new to you because they are more algebra related. On this chart, we're going to be taking notes of the main idea and giving examples of each of these properties. All right, so we're going to start off with one that you have seen since elementary school, and that's the commutative property. This property applies to both addition and multiplication, but first we're going to start off with the commutative property of addition. I want you to either highlight or underline the CO and the word commutative because we have an acronym that helps us understand this property, and that is change order. And so when dealing with addition, if the left side of the equal sign is in a different order than the right side, then that is completely fine. And so I have 3 examples of that for you, and they get more difficult with each example. So go ahead and look through those and copy them down. And as you can see, since we're using that addition sign, both sides of the equal sign are equal to one another. The commutative property also applies to multiplication. Again, let's highlight or underline the CO and commutative property. And again, we're going to be changing order, and now it's the same exact idea, but now it's with multiplication. So I still want you to copy what is written down under main idea. Repetition helps you learn. And so, but these examples are going to be dealing with multiplication. Really quickly, I want to discuss a few of these examples and just explain it to you for those of you who may be a little confused about these properties. So, for example, let's look at the first one. 7 times 9, that's going to give you 62. In addition, 9 times 7 is also going to give you 62. As we work down with our examples, we're going to see variables, we also see parentheses, we see other operations besides multiplication. The last one has addition in it. But basically just refer to that first example. Changing the order of the multiplication is still going to give you the same answer. I want to look down at the last example because it has addition and multiplication within it. Because of the commutative property of multiplication, that's where you see that the order of the 8 changing from one side of the equal sign to the other. But also, you could possibly see, and not in this specific example, but in a future example, since we know that with addition, we can also move the order. What is inside of these specific parentheses, since it's addition, those variables could also move order, and both sides of the equal sign would still be equal. All right, so now we're going to talk about the associative property, which also has a property of addition and a property of multiplication. Let's go ahead and highlight the 2 S's in the word associative. When I think of the associative property, I like to think of the word associate, and when you associate with someone, you're typically friends with them, and that kind of helps us understand what is happening on either side of the equal sign. So the order of the terms or the elements is going to stay the same. However, the elements are going to group or associate with a new friend on either side of the equal sign. So the reason why we highlighted the two S's is because that's a little acronym for slip slide. So the parentheses are going to slip off elements on the left side and slide onto different elements on the right side. So here we can see some examples of that. So as you can see, the terms stay within the same order. However, the parentheses are changing who they're grouping with, who they're associating with. Okay, so now let's see how the associative property applies to multiplication. Again, I want you to highlight or underline the two S's in the word associative. Again, I want you to, even though the main idea may be similar, I still want you to write it because repetition helps you learn. Okay, and so they're going to, again, the terms are going to stay within the same order. However, the elements are going to group or associate with a new friend. So thinking of that slip and slide acronym. And so now let's look at a few examples that deal with multiplication. Okay, so I'm going to just explain a little bit the first example. So if we follow our order of operations, when we do 2 times 3, we're going to get 6. And then when we do 6 times 7, we're going to get 42. Okay, so on the left side of the parentheses, on the left side of the equal sign, we have 42. If we do 7 times 2, then what we're going to get within those parentheses is 14. And if we multiply that by 3, we're also going to get 42. So there you can see how even if the parentheses slip and slide, then what is on the left side of the equal sign still equals what is on the right side of the equal sign. Next, we have the additive identity property, and we're also going to see it with multiplication. So that'll be the multiplicative identity property, or you can call it, this one you can call the identity of addition. And when you hear this property, I want you to think of identical. And with the additive version, the addition version, we are going to add 0 to one side of the equal sign in order to get an identical answer. So let's go ahead and look at some of our examples. So it may seem pretty self-explanatory. It'll be a little bit different when we're dealing with multiplication, but adding 0 to one side of the equal sign will give you an identical answer. With the multiplicative identity property, it can also be called the identity of multiplication. It's going to be a little different to create one side identical to the other, since addition and multiplication are different. So you're going to multiply by 1 to one side of the equal side in order to get an identical answer. And here are some examples of that. With the additive inverse property, this is probably something that you're going to recognize from a recent math class. And when you hear this term, I want you to think of opposite. This is when you add the opposite or the inverse of the element to cancel out and make 0. So here are some examples of that. For the multiplicative inverse property, I also want you to think of opposite, but this time with multiplication, in order to cancel out the element or make 1, you're going to be multiplying by the reciprocal. So let's look at some examples of that. So if 1/8 is my term, so I'm going to circle that in blue, then I'm going to multiply the reciprocal, which would be 8/1, or simplified that is 8. And so when I multiply 1/8 times 8, I get 1. I want to make a note about the next one real quick. This says, so the term would be -3. If I multiply that by its reciprocal, then it would be times -1/3. Okay, and so that is the reciprocal that I'm multiplying by. So just make sure you fix that. Go ahead and fix that on your notes, and that's going to give us 1. And then the next example is showing us it with the variable x, and that's just representing how you could insert any number in there, and multiplying it by its reciprocal gives us 1. I know that some other math teachers in the building and at Salem, they call it the reciprocal, and if that helps you remember what to do with reciprocal, then that's good to note, but the proper term to call it is reciprocal. Now we have the multiplicative property of 0, or also called the 0 property, and this one, the idea of this one is that anything multiplied by 0 is equal to 0. And so here are some examples of that. Moving on to the distributive property, my favorite property, and this is the sharing property. If you multiply the element on the outside of the parentheses to all elements inside the parentheses, that is when you distribute. So here are some examples of the distributive property. So on the left side of the equal sign, you see the original form. And then on the right side, you can see how it was distributed. I'm going to show you that process real quick. So the 5 is going to share to the x, and the 5 is going to share to the -2. And so that's how we got what is on the right side of the equal sign. Reflexive property, think of a reflection. And so the left side value is going to equal the right side value. And it's basically a reflection. They mirror each other. The symmetric property, think of symmetry. So I'm going to draw something off to the side. So here is a heart, and if it was symmetric, then if I was to cut it in half and fold it, everything on the left side of the heart would match the right side of the heart. So that is like the basic gist of this property. This property is going to use the words if and then. So if blank, then blank. Another memory trick with this specific property is that it has 2 M's. So think of that, and we need if and we need then and 2 M's and symmetric. And so here are some examples. If x equals 4, then 4 must equal x. If p equals y, then y must equal p. If 7x plus 2 equals 9, then 9 equals 7x plus 2. So basically you're including the words if and then you're doing the reverse of what is before the if, that you're doing the reverse of that after the then. With this property, as long as you look out for those words if and then you should be good. Moving on to the transitive property, this just builds from the symmetric property. So with this property, I want you to think of transition, and we're going to use 3 words. So we're adding the word and in there. If blank and blank, then blank. And a way in which you can remember this is thinking of the word, so there's 3 words involved, and the word 3 starts with a T, and so does transitive. Okay, so let's go ahead and look at some examples so that you can visualize this a little bit better. Okay, if x equals y and y equals z, then x equals z. Okay, so let's color code this real quick. I'm going to use some highlighters. I'm going to make the x's yellow, and I know that yellow is a little hard to see. I'm going to make the y's green, and then I'm going to make the z's red. Okay, And then we're going to look to the left of the word then. So I'm going to draw a little black line before the word then. As you can see, the variable y repeats twice to the left side, but is not included on the right side because we are realizing that if x must equal y and if z must equal y, then we can say that x and z are equal. All right, so I'm going to read the second example, but then work through the third example with you. If m equals 8 and r equals 8, then m must equal r. That probably makes sense in your head. But now let's look at the third example because it's got a little bit more going on with it. All right, so I'm going to highlight the 7x plus 2, just that part of the equal sign, that side of the equal sign with yellow, and I'm going to do that over here because I see it again. I'm going to draw my line before the word then, and then I'm going to highlight 9 with blue, and it's over here as well. And then I'm going to highlight H with green. Okay, again, same thing happened. So the 7x plus 2, it repeated on the left side of the then, and so it is not included on the other side, and what we include on the other side is our 9 equals 8. The closure property, the main idea of this is it exists if all numbers in a problem are all members of the same set of numbers in the real number system. So if all numbers are in that problem are integers, or if all numbers in that problem are natural numbers, or if all numbers in that problem are whole numbers. Okay, but it only works for addition and multiplication. So you should kind of be seeing a pattern throughout these notes that a lot of these properties work for addition and multiplication. Okay, so let's look at some examples. All right, so a whole number plus a whole number is going to give us a whole number, and you see that with 7 plus 3, so 7 is a whole number, 3 is a whole number, and it gives us 10, which is a whole number. An integer times an integer is going to give us an integer. And so we see how that worked with addition and multiplication, but then below we see how it does not work with subtraction, because if we have the whole number 5 and we subtract the whole number 18, we get negative 13, and negative 13 is not a whole number, it is an integer. You are going to use the substitution property a lot in algebra, and you probably used it in your previous math course. The main idea of it is a value may be substituted for its equivalent part for equal parts. Okay, so let's look at two examples of that. So if x equals 3 and x plus y equals 25, then you can go ahead and substitute that 3 in and figure out, so that you can figure out what y is equal to. And if you were to solve that, you would realize that y is equal to 22. Okay, so since we know the x, we can just go ahead and plug it in, substitute it in. The second example, the problem has parentheses 6 plus 4 and then multiplied by 9, and so we substituted that 10 in for the 6 plus 4 because we know that 6 plus 4 equals 10. And last but not least, the properties of equality. The main idea is that used when solving equations, whichever operation is being done on the left side, the same operation must be done on the right side. Maybe you've had a teacher before talk about how an equation is kind of like a balance that you use for weights, and you want to make sure, and I know that's not the most beautiful balance you've ever seen, but whatever you put on the left side, you want to make sure that it balances out, so you need to do it on the right side as well. And so let's look at some examples of that. Okay, so if I add 4 to the left side of that equal sign, I also need to do it to the right side. So this can be with adding, subtracting, multiplying, or dividing. Thank you guys for watching these notes. Make sure to reach out to your teacher if you have any questions. Have a good day.